In this video, we are going to find the derivative of Secx from first principle. We know that sec is the reciprocal of cos from trigonometry. So let us set our function f of x to be equal to sec x. Therefore, our f of x plus h will be sec x plus h. So the derivative, from the definition of derivative of a function, the derivative of sec x will be equal to the limit as h tends to 0 f of x plus h, which is sec x plus h, minus f of x, which is sec x, divided by h. Since sec is the reciprocal of cos, we can write this expression as the limit h tends to 0. So we replace sec with 1 over cos. So this will be 1 over cos of x plus h minus 1 over cos x divided by h. So we can simplify the numerator here. So we shall find the LCM. When we find it, this will be cos minus cos of x plus h. So this will be the limit of h tends to 0. So this will be cos x minus cos of x plus h over our denominator as cos x plus h times cos x divided by h. So we can write h here. Now you can see that this is the difference, cos. So we can use the trigonometric identity, which we know very well. We saw it in the derivation of cos, which states that sine of cos of an angle minus cos of another angle is the same as cos of A minus cos of B. We get negative 2 sine A plus B upon over 2, then sine A minus B over 2. So we shall apply it here. When we apply it here, we get the derivative of our function as the limit h tends to 0. So cos minus this cos of x plus h, we shall get negative 2 sine. Now let us add. When we add, we shall get x plus h, that is 2x plus h, divided by 2, we get x plus h over 2. Then for a minus b, that means x minus x plus h. So we get minus h. Now sine is affected by a negative. Since it is sine negative h, we can write negative sine h over 2. Hope you have got it. This is x minus x plus h, so we shall get negative h. Then divide by 2. So this is over cos of x plus h times cos x dot h. So you can see the negative and negative will disappear. I'm going to write this cos, I'm going to pull this cos, and I put it before the limit. I put it outside because it doesn't have bothered about the h. Now this is a 2, this is sine h over 2, so I will write limit. Before the limit I will say 1 over cos x and the limit as h tends to 0. So here we have sine x plus h over 2 times 1 over cos x plus h. So I'm left with this 2 here, sine h over 2 and this h. So I can combine them. I say times sine h over 2 over h over 2. And you know the implication of that. So you can see that if h tends to 0, here we shall have x plus 0, which is x. Here we shall have also x, but here we are going to have a 1. We've been seeing it is most of the derivation we have done. So the derivative will therefore be 1 over cos x times sine x times 1 over cos. 1 over cos. So you can observe that 1 over cos is sec, sine over cos is tan. So the derivative of sec x gives us sec x tan x. The derivative of sec x gives us sec x tan x.